Hello, this is a short introduction to acids and bases, which is specification point 5.1.3 for OCR A-level chemistry, and we're going to be using what's called the Bronsted-Lowry definitions. So, I'm hoping you're all familiar with the concept of an acid. It is a proton or H plus donor, and earlier on in your learning you would have come across it thinking that the opposite of an acid was an alkali, but really that was a little bit of a simplification. The opposite of an acid is a base, and if an acid releases protons, then the base accepts. So to spot an acid you have to have something that has a hydrogen, and quite possibly delta positive hydrogen is really what you're looking for, and the base, to be able to accept that, you are looking for a lone pair of electrons. So alkali fits into this because an alkali is a soluble base, and we'll look at that more next lesson. So the next thing is understanding that acids and bases fit together, and we have a thing called a conjugate acid-base pair. So if you pick an acid and you know it is a proton donor, which means it's going to release a proton, so you get H plus released, and then alongside that, so this was nitric acid, we have a nitrate ion. So here the nitric acid is, as the name suggests, behaving as an acid. Opposite side of the equilibrium we have the nitrate ion, which, if we consider the reaction going from right to left, this is accepting the proton, it is behaving as a base. So this is called a conjugate acid-base pair because they are essentially two sides of the same coin. This is the nitrate base, this is the nitric acid acid. They are linked in this equilibrium, acid on one side, base on the other. So I've picked another acid. Try pausing and just seeing if you can do the completion of this equation and writing in which is the acid and the base. It's not the most challenging one, have a shot. Okay, so hopefully you figured out that as an acid, methanoic acid is going to release H+, and the clue in the name, we're going to say this one's an acid. We need something on this side that's going to be the base, and so we're going to get the methanoate ion. So whenever you put methanoic acid, it's actually existing as a conjugate acid-base pair, going back and forth, releasing the H+ ion, and then having the methanoate accept it. Of course, we don't just have our acids existing on their own. We can quite often add an actual base, and in this case I've picked hydroxide. And so if you've got nitric acid that we looked at before, and you add hydroxide, you will have a neutralization reaction. We're forming water, and here we've got nitrate being the conjugate base here. Now if I try and simplify this, if I take out what's going on with the nitric acid that we just looked at, we know here nitric acid is an acid and the nitrate is a base. What we're going to do is number these. That's acid 1 and base 1. Here, hydroxide is reacting with the acid, it is accepting a proton, so it is behaving as a base. But it's now the second base that we've come across, so we're going to call it base 2. The thing is, this is also undergoing its own conjugate base acid-base pair, because the hydroxide is accepting a proton and forming water. And now if you look, these two equations added together, the H+ cancel out, and we've got the whole equation up here. And what this gets us to is the fact that well, if the hydroxide was behaving as a base, if we view the equilibrium going from right to left, water here is behaving as an acid. So right now, water is being an acid. And we're going to cover water in more detail next week, but basically, watch out for water. It's slightly more complicated than we might have led you to believe. So up here, we're going to complete the annotation for this equation. You must have an acid and base reacting together on the left, you must have an acid and base reacting together on the right, and you have to link them as the conjugate base pairs. So this is base pair, acid base pair 1, and this will be acid base pair 2. So here is the start of another equilibrium. Could you pause, have a shot to see if you can get what the products will be and figure out what the acid and bases are on both sides. Okay, so hopefully you did pause. I'm going to just keep going anyway. So here is hydrochloric acid. I know that hydrochloric acid is an acid. I have been paying attention and noticed it's called acid. So it's going to release H+, and it's pretty simple as far as molecules go. It must be a Cl- that we've got left here. I know, therefore this is an acid, and the chloride must be capable of behaving as a base. So I'm going to say this up here is acid number 1. Always pick the one that you can identify most readily. It must be reacting with a base, and that's going to have to be base 2, because base 1 is going to be the conjugate pair from the hydrochloric acid. So I know somewhere over there I'm going to have a chloride, and that's going to be base 1. Ammonia, of course, does have a lone pair in the nitrogen, making it capable of being a base. So let's think. We have the H+ being released by the hydrochloric acid, we have a base, put the things together, and we're going to get ammonium, which of course has an extra hydrogen and it's positive, so it is very, very much capable of being an acid, so that will be acid 2. Now, in exam questions, all they will ask you to do is work out what's acid and base on each side. I haven't done the final conjugate pair down here to be able to answer it, but for completeness sake, if you were to do it, you have the ammonia, as you know, excuse me, being a base, and the ammonium being an acid. Thank you.